Blacksmithing. Do-it-yourself projects and information for a blacksmith or silversmith. Written by Arthur Livingston. Narrated by Nicholas Santaseer. Chapter 1. Who's a blacksmith? A blacksmith is a person who creates and shapes different metals into various other structures by using the method of forging. In forging, a blacksmith professional exposes metal to extremely high temperature so that it can melt and be clobbered into the desired size and shape. In fact, a blacksmith combines three processes to design and refine shapes required for the finished products, including welding, heat treatment, and finishing. Welding refers to the process of joining similar metals. Modern professionals utilize a wide range of blacksmith tools to complete the job, where arc welding and forge welding are some common types. Blacksmiths are considered as the best wielder of metals. The black in the blacksmith is derived from the color of the metal's outer layer, which, when oxidized, turns into color black, especially when heated. The word smith comes from the phrase smite, meaning to hit. A blacksmith uses devices like chisels, anvils, and hammers to shape, mold, and bend metals after they go through the heating process. This process is called forging. To finish their work, forge welding is done by the use of arc welding and oxyacetylene. To provide apt heat treatment, metals can be hardened, normalized, tempered, and annealed. This will change the original crystalline structure of steel so as to give it certain properties required for different purposes. Based on the determined purpose, a blacksmith can finish metal in many ways. Common blacksmithing tools. The most common blacksmith tools include a forge, tongs, hammers, vise, and anvil. Forge. Metal forge is actually a heat source and can be a solid fuel like charcoal, coke, or coal. It can also be gas fuel, such as propane. Solid fuel forge is considered easier to design. It is actually a depression which will hold coals and variable air blast that raise temperature. Anvil. This is a basic blacksmith tool and refers to a block with solid face on which other objects are struck. The accessories which are utilized with anvil may include dies, known as fullers and swages. The swage is just like stencil built of steel or iron and is always put between heated metal and anvil. Hammers. The options for hammers may vary from one blacksmith to another. At blacksmith shops, one can find a wide array of hammers in different sizes and weights. Sizes of hammerhead may vary, based on the shape which is to be made, with the largest ones being utilized for striking metal into the shape and small ones for finishing purposes. Tongs. Tongs are utilized to lift metals out of a forge and grip it whilst it is being processed. One can find a wide range of tongs in different shapes and sizes. The size of tong depends on the size of the metal being processed. The shape of gripping end will change, based on how metal is to be gripped and also whether this is to be twisted, bended, and hammered. Besides the above-mentioned basic blacksmithing tools, a professional doing creative work will also have certain tools for etching or embossing on metal. Blacksmiths should also have certain safety gears and precautions when working. When striking steel, there are many pieces of steel or parts that come off and fly that could hit one's skin and eyes directly. In order to avoid these risks, blacksmiths should always wear safety eyeglasses to keep the eyes safe. To create a specific heating, today's blacksmiths make use of oxyacetylene, which is the same as the blowtorch. The color of a metal is an important sign of its workability and temperature. A forging heat, or a color of vivid yellow-orange, is the most excellent sign of heat for the forging. Forging is a method in which a hammer is used to form a metal. Heat treatment is the process by which the metal is put into heat until it is ready for molding. The rough metal outer layer is polished to make it smooth and to make the product look furnished and to ensure the product will be of the highest quality. The workplace for blacksmiths is usually a danger-prone area. They are often working with fire and scalding that makes them more prone to accidents. Eyes are usually affected by the fire ignited from the metals that they are currently working with. Poisoning from metals and heat fatigue are also a frequent danger they face. Chapter 2. Welding and Forge Welding. Fabrication, particularly when linked to industry, implies the building of structures, machines, products, or other equipment by stamping, cutting, shaping, joining, and even assembling components from raw materials, most often metals. It is commonly considered standard to assume that a fabrication operation includes welding as well, but I have chosen to separate this as some welding operations are now very specialist techniques and they merit their own section in this book. Fabrication shops. Often, a small business that specializes in this type of work is known as a fabrication shop, but it should be noted that in most instances, the individual parts and metalworking activities will overlap with machine shop work and sheet metal engineering or sheet metal work. What sounds like a simple activity, such as cutting metal, can mean many different things from shearing, sawing, to cutting torches and water jet cutters, and finally to laser cutting tables and plasma cutting. Depending on the speed and accuracy of what you want, and cost and quality requirements, you will always need to check on the capabilities and capacities of the fabrication facility that you intend to use. In general terms, the fabrication and welding shop is likely to cover many of the following activities: cutting, burning, bending, wheeling, shearing, folding, forming, punching, milling, tapping, turning, welding, soldering. Welding. Welding is often a major part of metal fabrication, and many formed parts and assemblies will be tack welded together prior to being checked for accuracy and fit. Welding is a fabrication method which is predominantly about joining metals or thermoplastics by causing coalescence, which is commonly achieved by melting the parts, adding a filler material to form the weld pool which, when cooled, becomes a very sturdy joint, the weld. This is different from brazing and soldering, which does not induce melting of the initial components, but melts a material between the components to form a bond between them. There are lots of different forms of energy which can be used for welding other than the gas flame most of us recognize, like laser, electric arc, electron beam, friction, or ultrasound. Welding is a skilled operation and requires several safety precautions to avoid burns, shocks, eye damage, fumes, etc. Starting in blacksmith shops with forge welding, shielded metal arc welding is probably the most common form of welding used today, as well as the semi and fully automated processes such as gas metal arc welding, MIG, and flux cord arc welding. As the technology advances ever onwards, so too do the welding systems like laser beam welding and electron beam welding. Some fabrication shops will offer specialist techniques such as MIG and TIG welding, which are briefly outlined below. MIG welding. MIG welding, metal inert gas, or metal arc welding, was originally developed for welding aluminum and other non-ferrous metals. It is usually an automatic or semi-automatic process, whereby an electrode joins two pieces of metal as a direct current is continuously passed through a welding gun. This is done at the same time as an inert gas is also passed through the gun, which stops any airborne contaminant entering the weld area. MIG welding allows the welding process to be much faster than other methods, which makes it ideal for welding softer metals, such as aluminum. It produces continuous welds faster than traditional methods, and produces cleaner welds. As it is very versatile, MIG welding can be used with a wide variety of metals and alloys. TIG welding. Tungsten inert gas welding, or TIG welding for short, is an arc welding process that uses a tungsten electrode to produce the weld. Similar to MIG welding in that the weld area is also protected from atmospheric contamination via an inert gas, usually helium or argon or a combination, and a filler metal is often used, although certain welds, called autogenous welds, do not require this. The constant current produces energy which in turn is conducted across the arc through a combination of ionized gas and metal vapors, which is known as plasma. TIG welding is often used to merge non-ferrous metals such as magnesium, copper alloys, and aluminum, and thin sections of stainless steel, and as the technique gives the experienced welder greater control over the weld, it has some advantages over MIG welding in that it can produce even higher quality and stronger welds. The filler rod is usually made from the same material as the base metal, and is used for reinforcing joints and welding heavy metals. Several joint types are used in TIG welding inclusive of butt joints, which do not always require the filler rod assistance, lap joints, corner joints, and T-joints. It is, however, more complex than MIG welding and harder to learn, and is much slower than most of the other techniques. Top fabrication shops. Finally, it is worthwhile checking to see if the fabrication shop offers other services which could be helpful to you. In today's fast-paced environment, it is worth seeing if your chosen supplier offers a one-stop shop, which could benefit you. Many will now offer other services such as design and prototyping, powder coating, assembly, testing and final inspection, packing and distribution. Some facts about welding process. Historical monuments, construction of building, bridges, shipbuilding, automobile, aerospace, power plants, refineries, and lots of manufacturing activities need the process, and welding is a part of it. The manufacturing industry came to know about the importance of service during the 20th century, and new equipment with the latest welding technology was introduced later, and requirement for welding supplies increased a lot. The welding industry should be equipped with modern tools such as electrodes, torches, consumables, and guns, and should follow the proper welding system with appropriate welding technology. There are different types of welding processes, and each one has its own merits and demerits. We talked about arc, MIG, and TIG welding, but there is also gas welding. Let me elaborate on that. Gas welding is also called oxy-fuel welding and uses gases to weld and cut metals. Stick or shielded metal arc welding is a manual arc process that uses consumable electrodes. Plasma arc uses plasma gas and has narrow penetration with greater energy concentration. Plasma arc cutting is an easy process if you follow these safety precautions. Do not touch any wet surface when operating the plasma cutter equipment, and don't use plasma cutters without any proper protection. Don't remove the ground cable, which is attached with the work object, and ensure that there is proper earth since it connects with high electric circuit. In welding, electrode is used to conduct current, and it is of two types such as consumable one and a non-consumable one. Shielded metal arc, gas metal arc, flux cord arc, and submerged arc comes under the category of consumable electrode methods, and TIG and plasma arc are non-consumable electrode methods. Apart from the welding products such as MIG, TIG, stick, and submerged arc products, the other products such as wire feeders, spot welders, multi-process units, and water coolers comes under the welding products. Welding equipment is a heat-generating equipment, and it is needed to be cooled by some machines. Water coolers are the instruments which prevent overheating of machines. These have the motors which create a flow of water and cool the equipment. Tungsten electrodes are used in tungsten arc process. Tungsten electrode is used to weld stainless steel and non-ferrous metals, and it is called as a steel electrode. Chapter 3. Silversmithing. Tools of the Trade. In years past, it was hard to separate the silversmith, or just smith or smithy, from his tools. When you said smith, you were referring all at once to the person, his tools, and the place where he worked. The same is still true today. Without his tools, today's silversmith has nothing. I am passionate about tools. My father is responsible for instilling an appreciation of, and respect for, good tools. He always said that with the right tools, you can do anything. He also said that you should always buy the best tools that you can afford. In tools, cheaper is not always better. The term silversmith covers a very wide range of techniques and necessary tools. For some, it is still all about banging on metal with a hammer, and I will admit there is something very satisfying about pounding on metal. For others, it is mostly about soldering one thing to another. Because the solders are not soft and require higher heat than, say, electrical soldering, it is considered to be more like welding. But everyone simply refers to it as soldering. Silversmiths also engage in casting silver. I do not do that, and will not be discussing the tools required for casting. Regardless of what you are doing, you need tools. Here are some of the basics. If you are going to shape metal by pounding on it, you need something to pound with, and something to pound on. Hammers, bench blocks, anvils, and stakes. There are all sorts of hammers, and each one is good for one or maybe two purposes. An embossing hammer, when driven against the inner walls of raised work, could elevate positions of the surface. It may also be used for planishing. A planishing hammer is useful for smoothing out imperfections and finishing surfaces of pieces that have been raised. Raising hammers are used on the outside surfaces to force the basic shape of various objects. Ball-peen hammers are used for flattening, shaping, or removing dents. Riveting hammers are used for forming rivets and tacking. Chasing hammers have either flat heads or domed heads. chasing can be thought of as a sort of stamping. Specially shaped punches are used to press a pattern or design into the metal. Most of these hammers will be made of drop-forged steel, but they may also be found in brass and nylon. Rawhide mallets are useful when you do not want marks of any kind left on your silver. For general all-around uses, I find a domed chasing hammer to be most handy. If you can afford only one hammer, that is the one I recommend. Bench blocks, anvils, and stakes fall into the same general category. They are what you hold the metal, either sheet or wire, against as you hammer it. Bench blocks come in a variety of shapes and sizes. In its simplest form, it is a square of hardened steel that sits on your workbench. The surface should be kept smooth and free of debris. I use one that is 4 inches square, and it is a fine size for most purposes. Blocks are also available with depressions in them in the shape of half of a ball. These are called dapping blocks and require a set of dapping punches. These are useful for doming. There are a number of other blocks with differently shaped depressions for all sorts of purposes. If you purchase an anvil, be sure the base is very solid and that it has a low center of gravity. Even so, it is sometimes a good idea to mount it to a piece of 2-inch by 6-inch board for stability. Anvils that have a cone on one side are particularly useful. Again, these come in all sorts of sizes and shapes. The size you choose will be determined by the size of the jewelry you wish to make. Stakes are hard to describe. They are made of hardened steel and can be held in place by a vise. They come in a wild array of shapes and sizes, and they are generally used for raising. There is one stake called a cow's tongue stake. It looks pretty much like its name. A bowl or vase that is being hammered into shape would be placed over the stake, and the metal would be struck from the outside against the stake. Whenever you hammer or bend metal, your work hardens it. It becomes more brittle the more that you work with it, and requires annealing to keep it from cracking and breaking. A torch, blacksmiths use a forge, is useful for annealing. A torch is necessary for soldering silver. If you are going to be soldering silver, you will need, at minimum, a torch, a soldering block, pickle, water for quenching and rinsing, copper tongs, silver solder, flux, and a flux brush. Protective eyewear is always a must. When I first started soldering silver, I wasn't at all certain that it was what I wanted to do. So, I started very small. I bought a butane-fueled mini torch, the kind you might use in your kitchen for making fancy desserts. No matter what you do, you absolutely need the other items mentioned above. That is, unless your only intention is to solder jump rings closed. Then a butane mini torch and silver paste solder in a syringe are all that you will need. Well, and something to polish them a bit when you are finished. I quickly learned that I liked soldering silver, and that in order to complete larger pieces, I was going to need a serious torch. I opted for a single fuel torch with 4 sizes of tips. The fuel I use is acetylene. The torch handle and tips are designed to mix the proper amount of atmospheric oxygen with the acetylene to get a nice hot flame. For the most part, the smallest size tip suffices for what I make. Occasionally, I use a larger one. I am glad that I have that option. Nothing is more frustrating than having this great idea and not having the tools you need to accomplish it. As far as soldering blocks, boards, and pads go, the smaller you can use, the better. The block is a heat sink, as is all the air around it, and the larger it is, the longer it takes to heat it up and heat the metal that is sitting on it. That is why some smiths prefer charcoal soldering blocks. They're usually small, and once you heat them up, they stay quite hot for a long time. And that is their main drawback. They can get so hot that it is uncomfortable to move your work around on them with your hands. Also, they tend to crack as they cool, and for this reason, it is best to wrap them with binding wire before you begin using them. There is a magnesia block option. They heat and cool quickly. They are not really made of magnesium, which is quite flammable. The surface of the soldering block does degrade and become pitted with each use, but they are easy to make true once again. I just move mine around on the concrete outside of our workshop with a circular motion, and in a few moments it is nice and flat once more. There is a whole host of soldering boards that can be useful. They are made from a number of different materials. Some are of transite, which is very durable, non-asbestos, and withstands temperatures up to 2,800 degrees Fahrenheit. Ceramic soldering boards tolerate temperatures up to 2,000 degrees Fahrenheit. You can also purchase soldering pads made of calcium silicate. They also heat and cool quickly without cracking, and can be pinned into as the magnesia blocks. Once again, purchase the smallest surface for soldering on that you can use. It cuts down on the time needed to reach the melting point of your solder. Tripods with mesh screens are available that allow you to heat your workpiece from the bottom as well as the top. But keep in mind that all the air around your work will be sucking away the heat. I have one, but rarely if ever use it. Pickle is simply an acidic solution used to remove fire scale from sterling silver after it has been heated. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper. When you heat it, the copper is brought to the surface of the sterling silver. Copper is much more reactive with the moisture in the air than is pure silver. That, coupled with the heat speeds up the reaction, causes the copper to rust or tarnish much more quickly, and the surface becomes quite black. Also, some fluxes will become quite glass-like after heating, and they also need to be dissolved. Granulated pickles that you mix with water are most common, and generally are not considered as hazardous materials, which require a very large shipping fee. Copper tongs are required for placing and removing objects from pickle. If an iron bearing tool is used, you will plate copper onto your sterling silver. It is a good idea to mix a little baking soda into your rinse water to help neutralize the acid completely. Silver solder basically comes in 4 hardnesses: extra easy, easy, medium, and hard. The silver paste solder mentioned earlier is basically extra easy. You will need all but the extra easy for most projects. The first joint is always made with hard solder. It melts at the highest temperature, and subsequent joins will, then, not unsolder the first join. Use medium and easy solders as you work your way through your piece. If you are using a new sterling silver called Argentium sterling silver, you cannot use the regular hard solder with it. Argentium has had some of the copper replaced with germanium and melts at a lower temperature than traditional sterling silver. You can purchase solders made specifically for use with Argentium. Flux is what helps the solder to flow. An anti-flux may be used to keep solder from flowing where you do not want it. I have not used anti-flux. Generally, the solder will follow the heat, so if you are careful about how you apply your flame, you should not have a problem. Fluxes are all toxic. Care should be used in handling them and managing the fumes given off as you are heating them. There are liquid fluxes and paste fluxes. Earlier, I briefly mentioned polishing. After pickling, your silver will have a dull, whitish coating. You can remove this with a soft brass brush dipped in a solution of dish soap and water. The soap keeps the brass from being deposited on the sterling silver. This will give a very soft shine to the surface. For a brilliant hard shine, you will need a buffing wheel of either cotton or muslin. The type that is stitched is best. It holds together longer and throws off less lint. These can be mounted in a regular drill that is mounted in place. Just be certain that the buff is rotating in a downward direction as you are looking at it. That way, if you let go of the work, it will fly down, back, and away from you, rather than into your face. There are also many motors available for purchase. Some will run only one buffing wheel, and some will run 2. There are many grades of polishing compounds. Some will cut quickly and remove large scratches. Others are for final polishing. Ideally, you should begin with metal that is as free of scratches as possible. Once your work is soldered together, it is not always easy to get to all the areas that require polishing. The compounds are held against the buffing wheel as it is spinning at speed. This is called charging the wheel. Hopefully by now, you have some idea of the basic tools you will need to begin your foray into silversmithing. It can be very fulfilling. It can sound very complicated on paper, but when it comes right down to doing it, it's not all that bad. I remember my delight at my first soldering closed of jump rings. At that moment, I was hooked. Oh yes, you will melt things that you did not want to melt. That is part of the learning process. Chapter 4. Olet Fittings, Branch Connection, and Types of Olet Fittings. Olet fittings, generally called branch connection fittings or outlet fittings, which give an outlet from a greater pipe to a littler one, or one of a comparative size. Olets are branching fittings made by largest manufacturers of metal fittings like us. Olets offer a substitute method for connecting into the primary run and don't require fortification or reinforcement. Olets are pre-molded to the bend of the run pipe. Flat-based weldolets are accessible for connecting with pipe tops and vessel heads. The principal pipe onto which the branch connection is welded is for the most part called the run or header measure estimate. The pipe to which the branch affiliation or association gives a channel is called the branch or outlet measure. Branch connections are in all sizes, sorts, types, bores, and classes, in a broad assortment of stainless steel, chrome moly, and distinctive amalgams combinations. Outlets are mostly utilized for branching on high weight pressure and high temperature applications. Maximum admissible weight pressure of a fitting is same concerning connected straight consistent or seamless run pipe of proportionate material. Outlet pipe fittings materials and grades: weldolets, threadolets, sockolets. 1. Stainless steel outlet fittings. ASTM/ASME SA 182F GR 304, 304L, 304H, 304N, 304LN, 316, 316L, 316H, 316N, 316LN, 309L, 310, 317, 317L, 321, 321H, 347, 347H, and UNS 31254, 254 SMO. 2. Carbon steel outlet fittings. ASTM/ASME A105 /A350 LF2, ASME SA105, A694-F42, F46, F52, F60, F65, F70, A36, A516, GR, 70, 60. 3. Alloy steel outlet fittings. ASTM/ASME A182 GR F1/F5/F9/F11/F22/F91. 4. Duplex steel outlet fittings. ASTM/ASME SA 182F GR F44, F45, F51, F53, F55, F60, F61, Workstoff number 1.4462. 5. Nickel alloy steel outlet fittings. ASTM/ASME SB 256 GR, nickel alloy 200, nickel alloy 20, mono alloy 400, inconel alloy 600, inconel alloy 625, incalloy alloy 800, incalloy alloy 800H, incalloy alloy 800HT, inconel alloy 825, alloy 20, Hastelloy C-276, Hastelloy C-4, Hastelloy C-22, alloy 6XN. 6. Low temperature pipe outlets. A/SA 350 LF2, LF3. Outlet fitting are also available in other metal like titanium, aluminum, bronze, lead, tantalum, zinc, brass, etc. Application or uses of outlet fittings are used in a wide range of industries. Some of them are power plants, water pipelines, refineries, food and beverages, pharmaceuticals, textiles, railways, petrochemicals, nuclear plants, sugar mills. Types of outlet pipe fittings. 1. Brazelet. Brazelet is usually generally and mostly to interface or associate the sustained fittings. Brazelet is the same as a weldolet and is an awesome fitting for metal pipes, copper tubing, and iron pipes funnels with brass. 2. Couplet. Couplet fittings are planned for use in fire/fire protection sprinkler structures and other low-weight channeling applications. 3. Elbolet. Elbolet is used on 90-degree long-radius elbows, can be delivered for short-radius elbows, for thermo well and instrumentation affiliations. 4. Flexolette. Flexolettes resemble weldolettes with a minor refinement, i.e., flexolette has straight bore, while weldolette has diminished bore. 5. Insert weldolette. Insert weldolette is the most broadly perceived of all branch associations, and is welded onto the outlet pipe. 6. Lateralette. Lateralettes are an assortment of weldolettes. You need to associate it in the same way. However, these lateralettes make a 45-degree association with the standard pipe rather than a 90-degree. 7. Nippolette. Nippolettes is just a mix of olettes with pipe nipples. These olettes work like the weldolettes or threadolettes, but they come with a nipple. 8. Sockolette. Sockolettes are in a general sense like weldolettes and threadolettes, beside the root that in sockolettes there is one-of-a-kind connection-suited welding. 9. Sweepolette. Sweepolette is a formed, basically sustained, butt-weld branch relationship with a low-stress heightening component for low weights and long depletion or exhaustion life. 10. Threadolette. Threadolettes resemble diverse olettes. The primary difference is that this olette is outfitted with female threaded association. 11. Weldolette. Weldolettes, or welding olettes, or welding branch association fittings, are the most understood among all the olettes. These are for the most utilized and arranged as butt weld fittings, as these are welded into the branch pipe. Manufacturing standards. ASTM A182 ASME SA182 Standard specification. ASME B16.11 Forged fitting socket, welding and threaded. MSS SP-97 Integrally reinforced forged branch outlet fittings, socket welding, threaded and butt welding ends. Important industrial metal alloys and their uses. Metals in the form in which they are received from nature are not useful for many types of applications. The discovery of alloys is considered no less than a revolution that influenced a number of industrial applications in a big way. Today, iron and aluminum alloys, and those of a number of other metals like tin, cobalt, nickel, gold, and silver, form the base of many important industries. The advantage of alloys is that they exhibit properties of all the constituting metals. For example, these alloys exhibit better thermal properties, tensile strength, and wider range of melting points. Here are some sections about the most popular alloys, along with their industrial uses and applications. Copper alloys. Used for applications with low friction requirement. Brass is one of the popular metal alloys made by mixing copper with zinc. Valves, locks, bearings, and gears are some examples of these applications. Moreover, brass is known for its recyclable nature. Another common copper alloy is bronze, which contains tin as another constituent metal. Apart from being a popular material for sculptures, bronze is also widely used for making window weather stripping and automobile transmission bearings. Aluminum alloys. Needless to say, the aluminum alloys are the most popular materials that have great importance in many industrial uses. Consisting of aluminum, nickel, and cobalt, alnico is one of these alloys and is used in electric motors, cow magnets, sensors, and microphones. Duralumin is made of aluminum, copper, manganese, and magnesium, and is an extremely popular alloy for aircraft structures, truck wheels, auto body panel sheets, forgings, pistons, and many other applications. Among other aluminum alloys is magnesium, which is also used in many automobile and aircraft parts. Iron alloys. Iron needs no introduction for being a popular choice for many metal alloys like steel and stainless steel. Steel is extremely admirable for its high rust resistance, tensile strength, and welding ability. The alloy is a useful material for the construction of railways, roads, bridges, and skyscrapers. Stainless steel is a famous variety of steel and is used in making surgical instruments, industrial equipments, bridges, and aircraft and automobile body parts. Iron alloys with carbon as an important constituent are extensively accepted. Wrought iron, for example, has applications like manufacturing of gates and furniture items like racks, tables, desks, and chairs. Pig iron is used in blast furnaces, and different varieties of cast iron are used in machine tools, gears, crankshafts, and cooking accessories like pans. Other metal alloys. Tin is also used as the main constituent for many alloys like pewter and solder. While pewter is mainly used as a decorative material, solder is a widely used material for joining, called soldering, metals, for many important industrial applications. Sterling silver is a well-known alloy of silver. It is useful not only as a jewelry material, but also for making medical and musical instruments. Nichrome, an alloy of nickel, is used in explosive industry for electric ignition systems. Resistance wires made of this alloy, too, are popular. Chapter 5. History of Platinum Rings and Japanese Swords. Platinum is a chemical element that got mentioned first back in the 16th century in Europe. There is, however, evidence that this element was used in ancient Egypt and early South American civilizations in jewelry. It was Julius Caesar Scaliger, an Italian humanist, that made note of the metal in 1557 and named it Platina del Pinto, which in Spanish means a silver-like substance from Colombian Pinto River. Whereas gold has over the centuries been the major exchange in engagement ceremonies and weddings, platinum has become the most popular choice in the last decade. The strength and high melting point of this metal is what caught the attention of many scientists, but with plenty of extraction challenges of pure platinum, delays in use were experienced till the end of the 18th century. In 1786, the first successful extraction was made by Pierre-François Charbonneau, and in good amount for that matter. He later presented Pope Pius VI with a platinum chalice and went ahead to establish a production company to start the platinum age in Spain. From here, it started being used in different items, including royal crowns and utensils, military aircraft, and engagement rings. This precious metal is rare and remains to be amongst the rarest on the planet. This rarity, coupled with its tedious and prolonged extraction, makes it amongst the most valuable substances too. Platinum rings have brought in lots of competition to its gold counterpart, with most people, including celebrities, now choosing platinum engagement rings as romantic gestures and status symbols. Why the fame? Platinum rings have become very popular, majorly because of their high-quality finish that makes them stand out from other rings. These rings are also quite low in maintenance, making them some of the best for everyday rings, like wedding bands and engagement rings. The metal also has hypoallergenic properties. These properties push their popularity to the top of the list, especially for individuals with sensitive skin. While such people face problems wearing the other metals, they find comfort in platinum rings, making a huge difference. Platinum rings are versatile in terms of design. They can be made into any desired design without losing their quality and elegance. You will find impressive collections of trendy engagement rings, so you'll be lucky enough to have one designed just for you and to your exact specifications. Platinum is shiny and silky, although not that shimmery. This white metal is therefore very easy to work with any outfit, considering you will be wearing your engagement ring or wedding band every single day of your life. The gorgeous metal makes the fingers stand out, compared to what sterling silver or white gold can achieve. You will love how unique the rings look on and off. The rings have lifetime beauty. They simply maintain their elegance over the years, and with so little maintenance, they are just what you need. When you choose the perfect fit and design, you can be sure to enjoy your platinum ring for a lifetime. Properties and uses of alloy steel. A combination of steel with different elements in various proportions is called alloy steel. The low alloy steels are generally referred as alloy steels, ranging between 1% and 7%. They are chromium, nickel, molybdenum, and vanadium. It contains about 1% to 5% of steel that is combined with other elements. Different alloy elements have unique properties, and adding these elements improve various qualities. Adding chromium improves the temperature strength to heat treatment. Nickel is added to improve toughness. Molybdenum increases the strength of the material, and vanadium increases the deoxidizing capabilities and offers corrosion resistance. All low alloy steels provide good toughness, torsional, and fatigue strength. They also have photoactive and semiconducting properties that make them fit for electronics applications. They are used as good catalysts for various industrial applications. With a range of properties, they remain as the cost-effective additives that are combined with steel alloys. The common properties of alloy steel are corrosion resistance, machinability, hardenability, and weldability. Corrosion resistance. Corrosion is a phenomenon in which the metal is corroded or destroyed due to oxidation. This causes rusting of the metal surface. It has corrosion resistance properties to stop the rusting of the metal surface. Chromium, nickel, molybdenum, and vanadium alloys show high resistance to corrosion. Machinability. It is the capacity of the metal to undergo changes easily when subjected to various mechanical processes to get the desired result. Chromium, molybdenum, and nickel show very good machinability. In some cases, it should be annealed. Hardenability. It is the property of the steel alloy to be hardened after heat treatment and cooling. In this process, the metal transforms from an austenite to a martensite at a particular temperature condition. All the low steel alloys show good hardenability. Weldability. It is the ability of the metal to undergo the process of welding to be welded or joined to other surfaces. All alloy steels have good weldability. With the combination of molybdenum, chromium, and nickel, preheating and postheating must be done while welding is carried out on large sections. Uses of alloy steel. They are used in various applications such as pipelines, auto components manufacturing, electric motors, axles and shafts of power transformers, generators, aircraft engines mounts, landing gears, wear-resistant coatings, manufacturing power electronics components, hot zones of furnaces, electrodes manufacturing, solar cell coatings, magnets, radiation shields, forging dyes, oil and petrochemical industries, production of lubricants, and smoke suppressants. Gold. In World of Warcraft, gold is definitely one of the very most important commodities. Lots of people believe that gold is extremely tough to earn amongst gamers, and most of them turn to buying gold for cash. Some individuals who did this appeared getting banned by the World of Warcraft servers, while others got their account hacked with the very people they bought gold from. Even though you can find trustworthy websites that offers gold for World of Warcraft players legally and honestly, you need to bear in mind there are plenty more methods for getting gold on your character without using real money. So, listed here are the techniques to know how to earn gold to your character effortlessly without using real money for it. Most notably, you should keep in mind that you can get a variety of professions that your character might take up in the game. Many of these characters will surely earn a lot of money because the occupation is extremely popular by most players. The initial profession is blacksmithing. This is definitely one of the secrets for making big money in the game. Characters in the game need blacksmiths to renew things. As a result of the constant requirement of renewing things, this profession will always be popular. An example can be producing sharpening stones and grinding stones. Enchanting is an alternative profession in World of Warcraft, which will make your character plenty of cash. This may deliver your character with good gold in World of Warcraft. Out of all servers in World of Warcraft, you will see that there is a large market in enchanting supplies, just like shards to dust. Attempt to look into disenchanting, besides enchanting, as can easily get your character the most profit. The disenchanting skills could make you stacks of components for other enchanters, which were too lazy to get them for themselves. Engineering can also be another great profession in World of Warcraft that can assist you to make big money for the character. The engineering profession could fabricate things which are highly busy by players, like bombs, explosives, and fireworks, simply to name some. Small pet vendors may also be greatly very busy. Though pets aren't really important to achieve quests and level up throughout the game, you'll discover that for whatever reason, World of Warcraft players love to get their characters small pets. Once you pick this profession to your World of Warcraft character, you may notice that will give a unique possibility for the character in making some huge cash around the game. All you need to accomplish is pick up several small pets, as you can, when you find yourself traveling through Azeroth and sell them inside the auction house. You may be amazed in respect to the amount of people aim for small pets for his or her characters. Instance runs is an alternative great option to make money for the character in World of Warcraft. You'll find that there are a great number of instances around the game that enables you to farm green items. This is usually bought from auction houses, where you can even disenchant them with the materials they are able to supply. After you reach level 70, it is possible for you to instance a loan, which will generate your character much gold. Japanese swords. The forging of samurai swords. Authentic Japanese swords are made from specialized Japanese steel, which consist of combinations of hard, high carbon content steel, and tough, low carbon content steel. There are qualities in both types of steel, both good and bad. High carbon content steel is harder, and able to hold a much sharper edge than low carbon steel, but it is brittle and can break in combat. Low carbon content steel will allow the blade to be more malleable, making it possible to absorb impacts without breaking, but this lower carbon content steel will become blunt in the process. The blacksmiths who forge authentic samurai swords take advantage of the best attributes of both of these kinds of steel. The blacksmith begins by folding and welding pieces of both types of steel several times, in order to work out most of the impurities. The high carbon content steel is then formed into a U-shape, and a piece of low carbon soft steel is placed in its center. The resulting block of steel is then hammered, or drawn out, to form a rough blank that will soon be a samurai sword. At this point, it may have only a slight curvature or none at all. The curvature of a samurai sword is attained by a process of heating and quenching the sword in water or oil. In this process, the sword maker coats the blade with several layers of moist clay slurry, which is a recipe that is unique to each sword maker. But in general, this composition can include clay, water, sometimes ash, grinding stone powder, and/or rust. The blacksmith will coat the edge of the blade with a thinner clay layer than the sides and spine. After this, the sword is heated and then quenched in water or oil. The clay functions as heat insulation so that only the edge of the blade will be hardened with quenching. This also causes the blade to form a slight curve due to the reduced strain along the spine. The quenching process also creates the distinct wavy line down the center of the blade. This is called the heimin, which can only be seen after the sword has been polished. The heimin is where most say the beauty is to be found in samurai swords. Each heimin is unique to the sword's maker and serves as the forger's signature. After the sword blade is forged, it will then be sent to be polished. The polishing of samurai swords can take anywhere between 1 and 3 weeks. The sword polisher will use finer and finer grain polishing stones until the sword blade has a mirror finish. This process is called glazing. This will make the blade razor sharp and reduce drag, making it much easier to cut with. The curvature of a samurai sword's blade also adds to its cutting force. Chapter 6. How to make a sword. The 6-step process. The process of making a sword is more than what you see in the movies. For many people, being a blacksmith is a fantasy where you pound steel against an anvil, dip it in water, and voila! You have a completed sword ready to mow down the evil hordes of creatures that lurk in the forest. But sword making is much more than this. Sword making is both an art and a craft, and it takes hard work, a lot of practice, and a significant amount of specialized tools to create a sword. It also takes many years of practice to become proficient at this skill. Before the blacksmith or swordsmith actually starts hammering or heating the metal for a sword, there's a lot of work to be done. The sword's size, shape, properties, and metal composition all have to be decided upon. These factors determine the amount of metal, the temperatures of heating, and the specific steps in the process that have to be completed. This article doesn't cover the complete art of sword making. It will only discuss and outline the process of smiting the blade of a sword. There are many different methods for making a sword, and the art has changed over the centuries as technologies, tools, and the science of metallurgy has changed. But for the past 500 years, there's been one method that still stands as the most common. This is the 6-step method. The first step is forging. A bar of the desired metal or combination of metals is heated in a forge, and then it is hammered into shape, the shape of a sword. This hammering process can take a long time, and it is called drawing out the sword. The sword is worked on in sections, usually around 6 inches in length, and repeatedly hammered and heated until it comes into the desired shape. This process is repeated many times, and the sword is often heated, then allowed to cool without hammering. This is required by the metal to keep the desired properties of strength and flexibility. Once this step is completed, the sword is in the proper shape, but the properties of the metal make it very brittle, and something has to be done to give flexibility to it. Step 2. Annealing. Annealing softens the sword and makes it easy to grind into shape. The sword is now heated and then allowed to cool very slowly. Often it is wrapped in an insulating material to slow down this cooling. It can take as long as 24 hours, and this annealing process makes the sword soft and easy to grind. Step 3. Grinding. Now the blacksmith uses a grinder to work out the edge and point of the sword. This would also be when any engraving is added. This is not a completed sword yet. It is still much too soft, so it must be hardened. Step 4. Hardening. Now the sword is heated to a very high temperature and then placed into a quenching tank. This is what we always see in the movies. This quenching allows it to cool quickly and evenly, which will harden the metal. After this hardening, the sword is brittle, and something must be done to make it strong, yet flexible. Step 5. Tempering. Again, the blade is heated and quenched, but now the heating is at a much lower temperature than was used at the hardening. This heating/quenching cycle may be repeated several times. This tempering allows the blade to be strong, but not brittle. This is one stage where the skill and experience of the swordsmith is invaluable. It takes a trained hand and eye to understand the properties of the metal. It will have a certain amount of flexibility, yet still retain its sharp edge. Now the sword is ready for completion. Step 6. Completion. The sword blade itself is now complete. Now the additional parts will be added, such as the pommel, the guard, and the hilt. For the past 500 years, the only way to learn the art of sword making was to find a skilled blacksmith or swordsmith that was willing to take you on as an apprentice. Because of the specialized skills and tools, and the skill that is required, this tradition remains the best way to do it today. Before you invest lots of time and money in equipment and materials, you should find a master that is willing to teach you the basics of the art. You won't have to devote your life to endless hours of hammering against an anvil, and with a little perseverance, a little patience, and some practice, you will be able to make some decent swords that you can be proud of. Forging a leaf hook, a step-by-step guide. It's a fun and educational way to pick up new skills and add something different to your repertoire of projects. The leaf hook is a very simple design, and doesn't require the use of any really advanced blacksmithing techniques. Therefore, I have classified this project as easy. I will lay out the process to forging this item in a series of steps to make it simple to follow along in your own forge. Step 1. Cut your length. Cut a piece of 3/8 inch round steel to length, approximately 12 inches long, using a red-orange heat and cutting off with your hot-cut hardy tool. Blacksmith's tip. There are several ways you can mark your steel when you are measuring for a cut. One method is to lay your steel ruler on the face of your anvil aligned with the back edge and measure out your desired length of the steel. Then, using the sharp edge of the back of your anvil, you can lightly mark your desired measurement by striking the steel against that edge with a hammer. You'll make a visible dent that you should be able to find easily even after heating to an orange heat. Another method for marking is using something called soapstone. It is a stone that is naturally soft, leaves a clearly visible white mark, almost like chalk, against the steel surface, and is very resistant to heat. This mark will remain quite visible, even after enduring high temperatures in the forge fire. Step 2. Forge a sharp point. Take a good orange heat at one end of your steel, then forge the tip to a shallow point. Use the far edge of the face of your anvil, holding the steel at about a 45-degree angle, and use light hammer blows to bring the tip of your steel to a point. Rotate the steel back and forth with quarter turns, using even hammer blows, to bring the steel to a shallow, sharp point. This is going to end up being the leaf end of the hook. Step 3. Create a shoulder. Now we will bring that pointed end to another orange heat and create a shoulder, about 1 inch back from the tip. To do this, measure, or just eyeball it, back 1 inch from the tip that you forged, and place that spot at a 45-degree angle on the far sharp edge of your anvil face. Using medium blows, strike the steel with the hammer face half on and half off the anvil. This will forge a ledge or a shoulder into the steel. Rotate the steel a quarter turn and continue forging. The idea is to create a much narrower diameter section that is going to become the stem section of the leaf, leading into the vine. Blacksmith's tip. Try to work quickly so you can avoid taking too many heats. Taking more heats increases the scale that forms, causing you to lose mass. Each heat also increases the chances that you might burn off the leaf at this delicate end as you continue to thin out that steel. If you see sparks jumping from your steel, you have begun to burn your steel. Try to avoid heating to the point of sparking. Step 4. Draw out the stem. Taking another orange-yellow heat along about a 2-inch section, just behind the leaf where you've started to form the stem, bring the piece back to the face of the anvil. Leaving the unfinished leaf section hanging off the back edge of your anvil so you don't damage it, begin drawing out the stem portion. Create an even taper about 2 to 2.5 inches long using overlapping hammer blows, starting from the back section of the heat and working towards the stem. Make quarter-turn rotations to draw out the stem evenly all along its length. Step 5. Bring the stem back to round. By now you have probably noticed that as you are forging the stem, you are turning your round stock into square. You will find that blacksmiths do a lot of making round things square and making square things round. It's just a normal part of the process of forging steel. Now that you have drawn out your stem to your desired taper and length, you want to bring that square stem back to its original round shape. Do this by knocking the corners in. After bringing the length of the stem to a red/orange heat, hold the steel so one of the square edges is pointing straight up, and using light overlapping hammer blows, knock the corners flat so that you are creating an octagon. Do that on the quarter turn edge as well. Blacksmith's tip. Remember that everything you are doing with the hammer on the top of the steel, the anvil is doing with equal force to the bottom of the steel. That is why you only use quarter turns when bringing the square steel back to round. As you flatten the corner on the top of the square, the anvil is flattening the edge on the bottom. Once you have the octagon shape, go back again and knock the corners off the octagon, and lightly tap down any edges that persist. You should be able to do all of this in one heat. As the steel cools, it doesn't move as much under your hammer blows, and this is the ideal time to refine the surface with your hammer. You should be able to take out most of the lumps without drastically moving the steel since it has cooled a bit. Step 6. Flatten the leaf. This is where the fun begins. Get ready to watch the magic happen as the leaf takes its final shape right before your eyes. Take a good yellow heat on the leaf portion of your steel. Be careful not to burn the tip. Lay the leaf section down flat on your anvil face, and using straight up and down medium strong blows, hammer down on the leaf section and watch it begin to flare out. Make adjustments to your hammer blows, hitting one side or the other to keep the leaf edges flaring out as equally as possible. Use stronger blows at the base of the leaf near the stem, and very light blows up near the pointed tip of the leaf. You want to keep that point, and hitting too hard can mash out the sharpness of it. Step 7. Add veining detail to the leaf. There are several ways that this can be done, but the way I do it is quite simple and creates an elegant look to the detail of the leaf. Using a broad-bladed chisel with a fairly dulled point, you can strike nice smooth-looking lines into the surface of the leaf. Start by making the spine of the leaf. Beginning at the very tip, place your chisel so that it will make a line down the middle of the leaf. Strike solidly, and only once. Move the chisel back a bit to continue the line down the center of the leaf. Make sure your chisel is sitting in the groove of your last mark so that you create a single smooth line. Once you've made a line down the center, start making the angular veins. I typically make 3 veins on each side of the leaf, but that decision is entirely up to you. Make the veins at about a 45-degree angle to the center line you made. This is where the art comes in, so just have fun making your own look. Blacksmith's tip. You may have realized while reading through Step 7 that this step might be very difficult to do with only 2 hands. You really need a third hand, one to hold piece, one to hold the chisel, and one to use the hammer. So a trick I've made for myself is to take a heavy weight, in my case a few lead discs, and attach it to a chain. I've attached the end of the chain to my anvil stand, and whenever I need an extra hand to hold something down while I'm chiseling or using a punch, I throw that heavy chain over the anvil and let it hold the work down, while I free up my other hands to use the tools. There are also hold-down tools that you can forge for yourself that do a great job as well. Step 8. Create the bends in the vine. Now we are getting to the part where a vise and a bending tool can come in handy. I made a bending tool by taking some angle iron and drilling a couple pairs of holes in one face of the angle iron, one pair fairly close to each other, the other pair a bit further apart for making different size bends. I fastened a couple of smooth bolts into those holes, and when clamped into the vise, this makes a good tool to bend hot steel around. So take your piece you are working on and heat a portion of the stem a few inches back from the leaf. Using your bending tool, make about a 180-degree bend. Do this again, bending the next section about 180 degrees back. Then again, heating and bending the next section back again. You should end up with a curvy shape to the vine. This part is all open to whatever artistic inspiration you might have. Try to make the vine portion of the hook aesthetically pleasing and geometrically balanced. To finish the bends, take one last heat and bend the final portion about 90 degrees from the last bend to make the vertical portion which we will turn into the hook. Step 9. Draw out the hook. Now we will work through a process very similar to Step 2 in this guide. Forge a point to the hook end and draw it out. No need to make a shoulder here, we're just drawing out a straight taper all the way to the end of the hook. Once you've drawn out a nice even taper and are satisfied with how it looks, take that square and make it round, just like you did in Step 5. Step 10. Forge the hook and curl. Now we are getting to the functional portion of this project. Take an orange heat on the very tip of the hook portion of your piece, and using the very edge of your anvil, bend the tip over the edge of the anvil, making sure you are bending toward the back face of the piece. Rotate the piece in your hand, and begin forging that bend back on itself, creating a tiny little curl. This is both decorative and functional, as it will look great on the end of the hook, but also prevents anyone from hurting themselves on the sharp point of the taper you forged. Once you've made a small little loop, Take another orange heat and quench just the tiny curl you forged. This will prevent the hammer from disturbing the curl shape too much. Now, with the curl facing up, start forging a bend on the horn of your anvil, creating the throat of the hook. You can make this portion as deep or shallow as you'd like. Step 11. Set an indent for the screw. As a finishing touch, I like to set an indent somewhere in the vine for the screw to sit in. It helps give it a finished look. Take a good red/orange heat in the section where you expect to drill a mounting hold. Using a ball-peen hammer, place the ball direction on the vine where you want to create the indent, and use a soft-faced hammer to hit the face of the ball-peen hammer. Check your work after each strike, reset your ball-peen, and strike again until you have a good indentation that you are happy with. Finishing. Now that you have forged the hook, take the piece to a wire wheel and polish it up, or simply give it a coat of beeswax while the steel is hot. Finishing is up to you, and it is a part of how you will make your hook unique. Drill a small hole in the center of your indent and hang this piece of functional art in your home. I've had my keys hanging on one for many years, and I love it. Conclusion. Blacksmithing is one of the few trades, if any, where the artisan can make the basic tools he requires, using the very same blacksmithing process for which he will be using the tools. Indeed, for many years, a blacksmith had to either go to another blacksmith to get his tools made, not always a good idea, after all, he wants to provide the competition with good equipment, or make them himself. Today's blacksmith has a huge variety of tools and equipment available, but the basics are few and have remained substantively unchanged over the centuries from the time when metalworking began. At the heart of the blacksmith's shop is the forge. This is the fireplace where the metal to be worked on is heated to a temperature where it becomes malleable. The traditional forge was just a charcoal-fired hearth with bellows to provide forced air to control the heat. Today's blacksmiths still use the same system, although many of them now use modern electric or multi-fuel furnaces. Then there are the tongs, which are used to lift the metal out of the forge and hold it while it is being worked on. A blacksmith's shop will have a range of tongs in various sizes and shapes. The size of the tong will depend on the size of the metal being worked on, and the shape of the gripping end will vary depending on how the material is to be held and whether it is to be hammered, bent, or twisted. The anvil is the blacksmith's workbench. It is made out of a large block of iron or steel and is where the heated metal is placed so it can be worked on. Accessories that are used with the anvil consist of dies called swages and fullers. The swage is like a stencil made of iron or steel and is placed between the anvil and the heated metal. The metal, when hammered, will be forced into the cutouts in the swage and take their shape. The fuller is the opposite of the swage and is placed on top of the metal and hammered into it so that a concave depression in the shape of the fuller is achieved. Swages and fuller are often used together. An example of this could be to create a small, shallow dish with the fuller forcing the metal into the shape of the swage. Blacksmith shops have many standard swages and fullers ready to use, but many often need to make special ones for projects that require complex shapes to be created. A blacksmith shop will have a variety of hammers of different weights and sizes. The size of the hammerhead will vary depending on the shape that is to be created, with the largest ones being used for hammering the metal into shape, and the smaller ones for doing the finishing. Besides these basic tools, a blacksmith doing artistic work will have tools for embossing or etching on the metal. There are many more tools that modern technology has provided the blacksmith, some using state-of-the-art metalworking technology, but if a blacksmith has the basic tools mentioned above, he is in business. This has been Blacksmithing, do-it-yourself projects and information for a blacksmith or silversmith. Written by Arthur Livingston. Narrated by Nicholas Santacier. Copyright 2017 by Arthur Livingston. Production copyright 2017 by Arthur Livingston.